Hey, Castle here, and welcome to Memphis Communiversity. Today I'm going to be working through the BC Integrals Review Worksheet. So these are all BC topics, or if you're in college, this would be Calculus 2, and it covers some different topics like U-subs, parts, or improper integrals. And if any of that is unfamiliar, or you just want to review those before doing this review worksheet, there are videos on the channel on each of those topics, so go check those out for some review. And as always, this worksheet and the answers to it are in the description below the video, so if you want to follow along or just do this worksheet later, you can find that in the description. So I'm just going to go ahead and get started with these first two. And once I move my hand, you will be able to see that these are indefinite integrals, and you can always pick out an indefinite integral by seeing that that integral is empty, there are no numbers with it. So the main thing to remember with indefinite integrals like this is they're like any other integral, except instead of plugging in numbers at the end, you're gonna just add a plus c at the end, and that's really important to remember on all of those. So we will get to that plus c later, so we'll just get started with the first one. On this first one, the first thing I see that I want to do is I'm going to switch that 4 over x squared to 4x to the negative 2, because when I have an exponent on the bottom, I'm always going to just move all of that so that I'm going to be able to do power rule pretty easily when I get there. So let's just get started with this one. The first thing, x cubed, is going to be a basic power rule where you add 1 to that 3 exponent and then flip it where the reciprocal is 1/4, and then you do 1/4 x to the 4th, not flipping it on that exponent right there. And the second part of this is going to be another power rule. When you add 1 to that 2, you're going to have, and when you flip it, you're going to have 1/3. So just in my head, I multiplied -6 by 1/3 and got that -2 right there, and then you've got x cubed. And on this next one, this one's a little bit different. You've got 2 over x, and that's going to be 2 ln of x. And the rule there is that when you're taking the integral of a number over x, then that integral is going to be the number times ln of x. So I'm just writing this out here, and that's just something that you want to be able to recognize when you're doing integrals. So I've got that 2 ln of x, and then hopefully you caught my mistake here. I forgot to do the -2x. So there should be a -2x between that 2 ln of x and that plus c. I left that out and just skipped to the plus c. So just make sure you've got that. And that should match the answer sheet below. So I've got the plus c, and that's my answer for that one. And the next one is another indefinite integral. And you can see this one is a little bit harder to work with. So to make it easier, I am going to split this integral into 2. Since they've got that common denominator, I can do that, and it's just going to make it a lot easier when we're taking the integrals. So the way I'm going to split this is I'm going to do x cubed over x, and then I'm going to do my next integral. I'm going to go ahead and change that square root of x to x to the 1/2 so that we can do power rule later. Put that over x. And I'm just going to simplify this as much as possible before I start to take integrals. So I'm going to turn that into integral x squared minus integral x to the -1/2. And that's just going to make things easier once we start taking these integrals. So this first one is just a basic power rule. We've got 1/3 x cubed. And then I've got plus. Make sure that you watch the signs here. And I've got another little mistake here, so make sure that you watch out for that. This should actually be a negative, because when you do the power rule here, you add the 1 to 1/2, and then you get a positive number. And so that positive times the negative here means that this should stay negative. So just imagine that this addition sign is a subtraction sign, and the rest is going to be the same. You've got 2x to the 1/2, and don't forget that plus c. So these are my answers here. Again, few mistakes here. I should have had a -2x right here on that first one, and then right here, just make sure you know that that's supposed to be a negative. But the main thing to remember here is to have that plus c on both of them. So now we're going to go ahead and get started on number 3. Okay, so this next one is not an indefinite integral, and so that means we're going to be plugging in numbers. So I went ahead and did the integral there. where that e to the negative x becomes negative e to the negative x. And so I can kind of check myself on that one by looking at that negative e to the negative x. And if I took the derivative of that, I would get e to the negative x. So what I did was kind of take a u-sub in my head with the u being that negative x, and then got that as my integral. And the next integral is just ex. I'm plugging in the 1 and the 0 now. So when I plug in the 1, I'm going to get negative 1 over e, where I put that e to the negative x on the bottom. And then I'm going to do plus e, because that 1 just makes it e. And then I subtract that negative 1 at the very end, so that I've got top minus bottom. And I'm going to end up with negative 1 over e plus 1 as my final answer. So just to review that one more time, the kind of tricky thing here is that negative e to the negative x that I got when I took the integral of e to the negative x. And that was just kind of a u-sub in my head, but I can kind of check myself there by making sure that the derivative of that ends up being e to the negative x. And then the next part is kind of easy, just that ex. And so then plugging in the numbers, I'm going to do top minus bottom. And so that top number 1 minus bottom number 0. And make sure that you're careful with your negatives at the end there. So you've got that minus negative 1, so you end up having a plus 1 at the end. Okay, so number 4 is a classic example of a u-sub problem, and in this case the u is going to be this inside function. It's in the parentheses, so it's pretty easy to spot, that x cubed plus 2. And another way that you can kind of be able to spot a u in a u-sub problem is you want to look for something where the derivative shows up in a different area. So in this case, the derivative of x cubed is going to be 3x squared, so that x squared shows up again here. And that is just a helpful way to remember it, because as you do the u-sub problem, you're going to want to be able to kind of simplify and cancel things out, and in this case that x squared is going to end up being canceled out since that is the derivative there. So let's just get started with this one. Like I said, the u is that inside function. The easiest way to spot it is just the fact that it's inside the parentheses. So I'm going to start by just writing all that out. I like to write out my u and du and all my x's in one place before I really get started with the problem. So in this case I've got u is x cubed plus 2. The derivative is 3x squared du. And what I'm doing here is, 3x squared dx. What I'm doing here is taking that 3 and I'm going to divide du by 3 so that all of my x's are on one side. And then you'll see that this 1/3 that's right here is going to end up being a coefficient in front of our integral. But I'm just going to go ahead and finish writing out everything I need to. Since I've got this 0 and this 1 and I'm doing a u-sub, I have to plug in those x's into my u and get new numbers for the u-sub. So what I'm going to do is take that x equals 0 and plug in the 0 so that my u ends up being 2, and with the x equals 1, the u is going to end up being 3 when I plug it into that u. So like I said, this 1/3 right here is going to be the coefficient of our integral. So I've got 1/3 integral, remember to plug in those u's, the 2 and the 3, and I've got 1/3 integral u cubed du. Sorry, that u is a little bit weird. But now that I've got that, I'm just going to take that integral. So I've got 1/3, and then I'm going to use the power rule to get 1/4 u to the 4, and then plug in those numbers. Before I plug in the numbers, I like to simplify as much as possible. So I'm going to have u to the 4th over 12, and then plug in the numbers. And from there, it's just making sure that you're careful with your numbers, because this is the last step. So I've got 3 to the 4th is 81 over 12, minus 2 to the 4th is 16 over 12, and the answer here is going to be 65 over 12. So this can be a lot, but just make sure that you keep everything kind of clean, and I think it's super helpful to just write out u, du, and your x's and your u's all before you get started with your integral. So on this next one, we have another u sub, so we're going to practice recognizing the u and changing the x's. In this case, your innermost function, your u, is that 3x right there. And so then your du is just going to be 3, and I need to put that dx, 3dx. And then you've got those x's that you need to change to u's by plugging them into the u. So my x's here are 3 and 9. So I'm going to write those out, and then when I plug them into that u, that 3x, I'm going to end up with u equals 9, and then for that other one, I'm going to end up with u equals 27. So now we can get started, and just like that other one, I didn't end up isolating the x, but in my head, I'm going to kind of divide du by 3 so that that coefficient becomes 1/3, and all of that goes in front of the integral. Remember not to put the x's there, but to put your new u numbers, which are 9 and 27. And then I've got f prime of u du. And so from there, it's just taking the integral. This is an easy integral because you've got f prime and you just take a step down to f. So I've got 1/3 f of u, plugging in 27 and 9. And this is when this table comes into play. When I do f of 27, I have to refer back to the table over here. And I've got 27, that goes to 1. So f of 27 is 1 minus, and then f of 9 is 5. So I've got 1/3 times 1 minus 5, and then your final answer there is going to be -4/3. Okay, on number 6 here, we have an integral, but we can't do a u sub with this integral. So this problem is going to be a parts problem. So we're just going to work through the different steps of a parts problem here. Let's just skip ahead a little bit. Okay, so the first step of the parts problem is you have to organize all of those numbers in the integral. And the way we're going to do that is by following this step called Lyautey. And Lyautey is just a helpful way to remember how to pick out the different parts of the integral as you're working through it. So Lyautey stands for logarithmic, inverse, algebraic, trig, and exponent. So we just want to see if we can recognize those different things. So on this problem, we have an x plus 5. So I'm going to label that as algebraic. And then we also have a sine x. So I'm going to label that as trig. I've got that a and t. And the reason we want to pay attention to that and label those on the paper or in our head is because the next step we're going to have a u, a du, a v, and a dv. And where Lyautey comes into play is basically starting with that L and ending with the E. You're going to follow that to choose your u and dv. So your u is going to be the first thing in Lyautey. So we don't have any logarithmic, we don't have any inverse. The first thing we see is an algebraic, so that's going to be our u. So I'm going to write that x plus 5. And then that means that our du is just going to be 1 d of x because the derivative of x is 1. And then you keep going through Lyautey. The next thing I see is t, trig. So that's going to be our dv. So the first things that you have to recognize are the u and the dv. And in this case, when we go from dv to v, we take that integral of sine x, and that's going to be negative cosine of x. Don't forget the negative there. And now that we've got all of that, the second part of doing this parts problem is to just follow this formula, which says that that integral is going to be u times v, we've got our u here and our v here, minus the integral of v times du. We've got our v and we've got our du right here. So we're just going to follow that formula, plugging in the things that we already found using Lyautey, where our u is going to be x plus 5, times our v, that's going to be negative cosine of x, minus, don't forget that it's minus, the integral of v times du. That should be minus. Let me fix that. Okay. So minus the integral of v, and that's going to be negative cosine x, times du, that's going to be 1 dx. The u's and the v's can get a little tricky. I always just make sure that I've got kind of a tail on my u's so that I don't mix those up. And now I'm going to go ahead and simplify that and take the integral, so that x plus 5 times negative cosine x stays the same. And I'm changing this negative to a positive because when I take the integral of the negative cosine x, I'm going to get negative sine x, so that negative has to become a positive. And remember, when we have an indefinite integral that doesn't have numbers on the integral, we have to have a plus c. So this is my final answer here. And that is a parts problem. The parts problems can seem a little bit tricky. Remember that we have videos on all of these topics, so if you thought that was hard or you want to review, then you can go to the parts video on this page. And the next thing that we have is what's called an improper integral. So let's start working through that one. Okay, so as you can see, there is an infinity on this integral, and you can't have an integral with infinity. So what we're going to do is something called the b way, which allows you to work through this problem using b instead of infinity, using a constant instead of infinity. So obviously, first thing I'm going to do is c to the negative 2x so that I can take that integral a little bit more easily. And the first thing that I'm doing when I'm taking this integral is I'm going to change the format of it to limit b going to infinity, integral 1 and b. So I've got that b there instead of an infinity. And then in the front, you have to have that limit. And so all of that is going to be the same, times c to the negative 2x d of x. And the next thing that I'm going to do is take the integral. So this is a little bit of a weird integral, but I'll show you the formula here. Let me move my face up to the top. Okay. So what I'm doing is I'm kind of just doing a u sub in my head, where the u is that negative 2x you see there. And then I've got times c to the negative 2x over ln of c. So that looks pretty complicated, but that's just one of our integral rules that I'm going to write out here, where the integral of a to the x becomes a to the x over ln of a. So as you can see, my a is that c, and then to the x, but I've got to the negative 2x. So when I did that u sub in my head, I'm just going to end up with a coefficient right there that's negative 1/2, and then the rest just follows the integral. You put all that over ln of c. And then remember, we have that 1 and b that we need to plug in and do our top minus bottom. So I'm going to write those out there, and now I'm just going to start plugging in the b and the 1. Remember that we've got limit b going to infinity, so when I've got that b, I'm actually going to plug in infinity. So the first thing is the top, which is the b, and when I plug it in there, I'm going to have 0, and I'll show you where I got that later. And then plus 1/2 c to the negative 2 over, where did it go? Once I move my hand, I'll explain this. So what I'm writing out right now just explains that 0. Since I'm plugging in infinity, if I had c to the negative infinity, then that would actually be 1 over c to the infinity, which is 0. So that's what happens when I plug in infinity for b. And then that second part right there, the plus 1/2 times c to the negative 2 over ln of c, is what happens if I plug in the bottom, which is 1. That negative 1/2, make sure that you change it to a positive, and then times c to the negative 2x, that x is 1, so you've just got c to the negative 2 over ln of c. And I'm just going to change the format here, putting that c to the negative 2 on the bottom, and then making that exponent positive. Oops, that's not showing up. Let me move it. There it is. Okay, so I moved that c to the negative 2 to the bottom, so that I've got 1 over 2 ln of c times c squared. And there's my finished product. Remember that when I did that top minus bottom, I think the trickiest little thing here is to remember to change that negative to a positive, because you've got minus negative 1/2 along with all of that, so it ends up becoming a positive. Again, we have a video on improper integrals, so make sure you watch that if that was confusing at all. And now we're going to move on to number 8. Okay, the next problem we have is something called a partial fraction. So the first thing that I'm going to do on the partial fraction is I am going to separate the parts of this really big integral, and when I do that, I'm going to take away that x minus 3 for now. It'll come back later. And on the top, I'm going to put a, and then I'm going to take that first parentheses that's on the denominator, and then I'm going to also do I'm going to add a b over x minus 2, which is the second part of that denominator. So what we did was just split up this denominator and put a and b over it, and then this x minus 3 is gone for now, but that's about to come back into play. So now that I've gotten all that written out, what I'm going to do is take that x minus 3 and start off with that, and then I am going to basically just cross multiply these two things. So first I'm cross multiplying a and x minus 2, and then I'm going to add b times 2x minus 1. And so what I'm doing now is I'm going to take that big thing, that x minus 3, which is set equal to everything cross multiplied, and I'm going to separate that into a system that has kind of an x equation and a non-x equation. So what that looks like in this case is I'm going to have a plus 2b equals 1, and really what I did there was I took that x from the x minus 3. I just took the x part because this is the x equation, and I set it equal to ax plus 2bx. My hand is kind of in the way right now, but you can see that bx, or the b times the 2x. So then that's going to simplify to a plus 2b equals 1. So even though you don't have any x's there, that's your x equation. And then the next thing that I'm going to do is my constants equation, which I just wrote there. So my constants equation is going to be taking only the constants in that big formula, or in that big equation. So I'm going to have that, let's see, I'll wait till my hand moves out of the way. So here I've got negative 2a minus b equals negative 3. So if you look at that top line, I took the negative 3 and didn't use the x at all and set it equal to negative 2a from that first part that we cross multiplied, and then a negative b from that second part that we cross multiplied. So that's your constant equation. So now that I've got my x equation and my constant equation, this is going to just be a system of equations that you can solve using substitution or elimination. In this case, I didn't show my work, but I did elimination, multiplying that bottom, that constant equation, the negative 2a minus b equals negative 3. I multiplied that by 2 so that the b's were eliminated and I was left with the a's. And then when I solved that using elimination, I got my a and my b. So in this case, I would get a equals 5/3, and I would get b equals negative 1/3. And then now that I have those, I'm going to go back to the first thing that I wrote when I split up that denominator and did the a and b. And I'm going to also take those numbers that I just got, and I'm going to rewrite that first thing using the numbers that I have. So instead of a on top, I know that a is 5/3, so I'm just going to put 5/3 in front of the integral, and then keep that denominator the same and have dx over 2x plus 1. So you see how this turned into this because the a is now 5/3. And I'm going to do the same thing with the b. That b is negative 1/3, so I'm going to have negative, let's just finish that out, negative 1/3 integral dx over x minus 2. So what I've done so far is I have just, well, I'll wait for my hand to move out of the way. I'm going to go ahead and finish this off. So what I'm doing now is the final step of the partial fractions equation, of the partial fractions problem. And so this first part, I've got the 5/3 becomes a 5/6 because I did a u sub in my head in which the u was 2x minus 1. So remember, when I do that u sub, I'm going to have a 1/2 in the front. So when I multiplied that by 5/3, I end up with 5/6. and again, my hand is in the way, but I'm going to have 5, 6 ln of 2x minus 1 when I do that u sub. And then the same thing happens with the other one. I don't do a u sub. When I do the u sub here, I don't have a coefficient that I need to multiply by negative 1/3. So the negative 1/3 stays the same, but I do have ln of x minus 2. So I just took all of this, and in this case, I just did the u subs in my head. Remember that 1 over u is ln of u, and then when you substitute those back in for u, you're going to get ln of 2x minus 1, and on this one, it's going to be the ln of x minus 2, and don't forget about those coefficients out in front. In this case, the coefficient goes from 5/3 to 5/6 because of that u sub, and because of the 2 in front of the x here. So all of that is going to be my answer on this problem. Of course, having the plus c because that is an indefinite integral. So I'm going to go ahead and box that because it's a little bit messy. So again, there's a video on partial fractions if you want to see it, but just a reminder that your steps here are going to be having the integral with a and b, and then you're going to cross multiply, create a x equation, and then a constant equation. And then you're going to do that system of equations to find your a and b, and then take those, plug them back into the original thing that you did, and then integrate. And oftentimes you're going to have, I think every time you do these, you're going to have an ln in that case. And then don't forget the plus c at the end. Okay, we have one more problem. This is another parts problem. You can't do a u sub here, so what we're going to do instead is we're going to make ourselves a little table that has u, du, and it's also going to have v and dv. And in this case, we can't use Lyautey because we just have f of x and g prime of x. But pay attention here to the fact that you have a g prime, and you don't want to make things more complicated by having a g double prime. So you know that the g prime has to be your dv, because when you integrate that, you're going to have g of x. But if your g prime of x were your u, then your du would be g double prime of x. So here it makes the most sense to go from f of x to f prime of x with your u and du, and to go from g prime of x down to g of x with your dv and your v. And then from there, we're going to use that formula that we used in the other parts problem that we had in this worksheet, where it's going to be u times v minus integral of v times du. So here it's just plugging things in, and then we're going to use that table that's given. So when we plug in, we're going to have u f of x times v g of x, and we're going to have to plug in that top minus bottom with the numbers that they're asking you to use. And then we're going to have minus integral v du, gx times f prime of x. So the first thing I'm going to do is all of this that's out in front using the 5 and negative 2 for top minus bottom. So I've got f of 5 times g of 5, top, minus f of negative 2 times g of negative 2, that's the bottom. And then I'm going to use this table on the side to get those numbers. So my fingers are kind of covering it up. Okay, there we go. That's going to give me negative 1 times 3 minus 8 times 4. So again, we're still working on this part. We haven't gotten to the integral yet. And the final number there is going to be negative 3 minus 32. And that's going to be negative 35. And then we've still got this integral, but it's given in the problem, and it's 6. So we're just going to subtract a 6 at the end from that negative 35. And your final answer is negative 41. Okay, so some of these were a little bit harder. Remember that there are videos on all of these different topics, so go check those out. And if the videos are helpful to you, go like them and subscribe to this channel and keep watching. Thank you.